Hello everyone. In this video, we are going to see the introduction to synchronous generator. The synchronous generator is, it's a widely used one, and this synchronous generator is a synchronous machine which converts the mechanical power into AC electric power through the process of electromagnetic induction. Though it works with an electromagnetic induction, the synchronous machine cannot run by its own. This synchronous generator always require a prime mover to rotate the field. So sometimes a DC machine or an AC machine can be used as a prime mover, but in certain cases of application, like the generator may employ the diesel engine, petrol engine, gas turbine to act as a prime mover. So here the synchronous generator are also called as alternator or AC generators. The term alternator came because the synchronous generator actually produces the alternating current power. So taking a generator and AC and both combined and named as a alternator, and it is called a synchronous generator because the machine will be run and produce the EMF at the synchronous speed. Synchronous speed is nothing but the magnetic rotating magnetic field speed. That's actually NS is equal to 120 F by P. Okay, so this is a simple introduction, and sometimes you may have a question: how do we compare the AC generator, that mean alternator, and the DC generator? Since the almost the process remains same, but still there are a lot of differences between the AC generator that's called as an alternator or the DC generator, which we are going to see right now. And here I have differentiated the property or a description that will suit to the alternator and the DC generators. Okay, I'm just taking a point by point of comparison. The first is definition. So when we take definition, the alternator is a device converts mechanical energy into AC. But in case of DC generator, it can be either AC or the DC electric energy. But the principle of working remains same. And when we talk about efficiency, the alternators are the one which are very efficient alternators, and generators are considered less efficient with the alternator. The output have higher values in an alternator, but where generator DC generator have a limited one when compared with an alternator. And the energy conservation is required. The alternator conserves more energy, but generator will not conserve much energy. So here all the comparison are made in terms of alternator and generator. And here there is a one difference. There is a one difference in the alternator and DC generators, just an opposite of working principle. In the DC generator, the field magnets are kept stationary and the armature of the generator are rotating. But in case of alternator, it is a vice versa. The stator of the, I mean, the armature of the machine will be kept constant, and field is act as a rotating one. Okay, and the excitation to the field in both places, in alternator and generator, the excitation to this field remains DC supply, and the alternators have a high and wide range of revolution per minute, but in case of DC generator it has a low RPM. Okay, so when the things, know the voltage generation, the alternator produce voltage only when we need it. Generators produce the voltage at all the times. And size of the machine, generally the alternator varies with difference in sizes, and the size of the alternator is much smaller when compared with the DC. And the brushes, generally DC have a brushes because of the rotating armature, where is last longer. And the battery, that means it's used for an excitation, and it's a kind of DC excitation. And everywhere, even now, alternators are widely used in the automobile industry as a charging system for the battery, and generators are also used in a large scale. And for charging a DC generators are applied. And the size, as I said, generally smaller in size, and the DC generators are larger in a size. So these are the major differences between the alternator and the generator. But rest of the operation, working principle, constructions almost remain same. But in case of DC generator, it's a DC supply. The armature holds a single winding. But in case of armature alternator, the alternators are available in single phase and three phases. So if a single phase alternator, the armature consists of single phase winding, and in case of three phase alternator, the slots and the winding will be provided for the three phases R, Y, B, and these three phases are 120-degree displaced when, and even if minimum two phases are required, okay, it's usually to generate the much EMF. So these are the simple differences between the generators and the alternators actually, right? So so the next video will be the construction of alternator. What a stator and how it will be made up of, what will be inside the stator, that means an armature, and what will be in the rotor, and how it will work, how the generator will be alternator will be operated, and how these things will be done. In the later videos, we will discuss a lot about the voltage generation, voltage regulation, the methods to derive the voltage regulation, EMF equation, and two reaction theory, slip test, and parallel operation of the generators, alternators. And there are much to learn about the alternators in the video. Thank you.